how do you find t at the end of the day, right? So how do you find the t? And not only that, how do you find the probability associated with that t? For instance, where t is greater than, 2, right? How do you find these probabilities? We know how to do it for z. How do you do it for t? Well, one thing that you could do is you could look at the back of your book. Usually in the appendix section, there's something called the t-distribution or the student's t-distribution that you could look at. And oftentimes it'll tell you, it'll have degrees of freedom on one side, right? So degrees of freedom, like 2, 3, 4, 5, right? All the way down. And then it'll show you either a one-tailed or two-tailed area. Like, so it might give you at 0.25, 0.10, 0.05, 0.025. I'm running out of space, right? So it might give you these areas. And so the number right here tells you the t-score at that place. So like this. If you wanted to know where the 25% cutoff is, so maybe like this, right? Does that look like 25%? Maybe a little more, right? So if you want to know what this t-score is for degrees of freedom equals 2 distribution, then you would look right here. If you wanted to know it for, 0.025, I should be here, 0.025, right? Then you would look here, right? So you want to look for degrees of freedom as well as how much of the curve you're trying to cover or not cover, right? Okay, so that's definitely one way you could do it. The other way you could do it is by using Excel. Just like how Excel will help you find probabilities and z-scores for the standardized normal distribution, you could also find it in Excel for the t-distribution. But it needs a couple of hints. So let's start off with t-dist. So t-dist is the case where you want to find the probability, but you have everything else, right? And what the t-dist will do is if you put in the degrees of freedom, right, degrees of freedom, and you put in the actual x value, you could think of the x value as the t value, and it'll only take positive t values. So for instance, a t value of 1, let's say, right? So these are my t values. And the number of tails, if you want this entire area, or if you just want that area alone, right? So you could either put in 1 or 2. Then it'll give you the probability of this area. So I can show you right here. So let's put in t-dist for t of 1, let's say, comma, and degrees of freedom 2. And let's look at what it might say for 2 tails. It'll say 42%. And if you look at this exact same thing, but if you look at it for 1 tail, it'll just divide this area in half, right? So 21%, 42%, it makes sense, right? And basically, this is giving you this area plus this area if you want 2 tails. But if you only want 1 tailed, it'll just give you this area, right? So let's say we want to know. So we know that for 95% confidence intervals, we often use a z-score of 1.96. And that will give us a tail of 0.025. Or if we count 2 tails, it'll be 5%. Let's see what this gives us for 1.96 when we have a degrees of freedom of only 2. So t-dist. So let's put in 1.96, right? if we put that in our z-score, we would get, only, if we put in 2 tails, we'd only get 5%. But let's see what we get here. Degrees of freedom, 2. And number of tails, let's put in 2, right? Do you think this should be more or less than 5%? Well, let's think about this. Remember, the t-distribution is like slightly smushed, so it's more spread out, right? It's more variable. And because of that, it's going to have these longer tails, right? So it's not going to be nice and, all compact in the middle. It's going to be sort of spread out. So we would imagine that it would have a fat tail. So I would say more than 5%. Let's see. And we see that it's almost 20% at t of 1.96, right? But let's put that same z-score in, right? So norms dist, right? Dist is whenever we want the probability, and put in 1.96. Oh, and we forget. Here we get the negative side. So we'd want 1 minus. And this gives us just 1 tailed. So I'm going to change this to 1 tail so we could look at it. Okay, so here on one of our tails, one side of it, it's almost 9.5%. Is still out there. But when we use z-score, only 2.5% is still out there, right? Okay, so, but let's look at this same t distribution for a very, very high degrees of freedom. Let's try 60. That's sort of like medium, right? Let's try 60. Even with something like 60, we're starting to get very, very close to the z distribution. But still, this guy is more variable than the z distribution. Let's see if we could go even higher. So instead of 60, I'm going to put in 120. Degrees of freedom of 120. And notice, we're getting closer and closer, but still, these are more variable than these, right? So let's go a little nuts. Let's put in like 1,000, right? See what happens there. We're getting super, super close, but still slightly more variable, right? So that's a good principle for us to know. The t-distribution, although it approximates normal, it approximates it from one side. So here's the normal distribution standard. It's 0.02499, right? There it is. And it's getting closer and closer to it, but it's approaching it from the high end, right? So these numbers are dropping, and getting really close to that, but not quite hitting it. Okay. All right. So now you know how to get the probabilities. But what if you have the probability and you want to find the t-score? What would you do? In this case, you would use the inverse, t-inv. For inverse. Here, you would put in the 2-tailed probability. So let's say we want to know, okay, what is the t boundary for if we wanted only 5% in our tails, right? So here's the situation I'm talking about for this one. So I'll draw it down here. So we have this distribution, and we know we want these to be 0.025, just like a z distribution. We want it to be 0.025. But we want to know what these numbers are here, right? We want to know what these numbers are. Well, it depends on your degrees of freedom, right? So let's try degrees of freedom of 2, 60, 120, and 1,000, right? Okay. So let me label this a bit. So here we get the probabilities from t-dist, and here are the probabilities from standardized normal distribution, or the z distribution. Okay, so now we don't want the probabilities. We actually want the t boundaries themselves and the z boundaries themselves. So if we wanted the z boundary at 0.025 or, at 5%, we would use norms inv, right? And we'd put in our probability. I forget if it's one-tailed or two-tailed. Let's try one-tailed. It's not one-tailed. We would need two-tailed, 0.025, and we get very, very close to negative 1.96, right? We had you guys just memorize that, right? But that's why. This is saying at negative 1.96, you have about 2.5% in that little tail. Now, what about the t? Now, in Excel, it's sort of inconsistent because for z, it gives it to you on the negative side. For the t, it only gives it to you for the positive side, so it's sort of confusing. But I often don't memorize that. I just try out a couple of things until it sort of spits out the thing I'm looking for. But you have to sort of understand how these things work so that you could predict, what's going on. Okay, so we'll use t inverse, right? And we want to know the probability. I believe this is going to be two-tailed, so 0.05, and degrees of freedom, let's say 2. And we get 0.05 and degrees of freedom. Just to test whether this is one-tailed or two-tailed, let me put that in. I believe you have to give it two tails. Right, okay. So you have to put in the two-tailed probability here. So that's 0.05, and then the degrees of freedom 2, right? And this will give us these boundaries. So it'll only give us the positive boundary, but because it's symmetrical, you automatically know the other side, right? So this would give us a boundary of 4.3. So remember, for a z-score, this boundary would be 1.96. But for a t-distribution with a degree of freedom of 2, this would be 4.3. That's quite high. Because remember, it's really spread out. You got to go way out far in order to get just that 2%. But what about degrees of freedom? What about this boundary for degrees of freedom of 60? What do we get then? We get something very close to 1.96. But it's a little bigger than 1.96. Remember, because the t-distribution is more variable, you have to go farther out there in order to capture just that small amount of 0.025%. I mean, 2.5% or 0.025. And if we go to 120, what we should expect is that boundary to come closer and closer to 1.96 from the big side, but not quite hit 1.96, or more closely, 1.9599 something. Yeah, so we're getting close to that 1.96 number, but still it's a little bit higher. And finally, when we just go buck wild and put in degrees of freedom of 1,000, we get something very close to 1.96, but still a little bit higher than 1.96, right? So those are two different ways that you could find the t as well as the probability that that t is associated with. But you always have to remember the degrees of freedom. And I even put it here, two-tailed probability. And you have to know the whether you want two-tailed probability or one-tailed probability, as well as your degrees of freedom. So that's what you'll have to know in order to do to look things up on a t-distribution.